Welcome, everyone. This is Alan Cheeves here at LIDAR Magazine. I appreciate you taking time to attend this morning. Got a great webinar for you. Aaron Lawrence, of course, from Woolpert, Mark Treiber from Teledyne Optech. I'm going to give you a quick introduction to who they are, as a lot of folks are still logging in. Appreciate you, those of you that are here on time or we're ahead of time. We appreciate that. We always are asked that, presentation slides, recording, certificate of attendance, all that will be sent within 48 hours. We'll follow up. If you need anything particular or have any issues with any of that, just reach out. My email will be on all those follow-ups. So again, this is, of course, LIDAR Magazine. You can expect a LIDAR emphasis today, but the core focus of our presentation will, of course, be Woolpert's experience with drone mapping. That goes back quite a ways. Aaron's going to speak to how long they've been in the game. They've done everything from fixed wing to, you name it, they've been involved with it. But few firms have had as much experience with drones and UAS as Woolpert. They're involved with all manner, all manner of LIDAR, all manner of surveying geospatial engineering activities. The last webinar, neat statistic, we did a year ago with Woolpert for aerial LIDAR. They had 700 employees, and as we updated slides today, they're up over 900. They've been acquiring firms recently. Aaron can speak to that. Recently acquired a bathymetric firm out on the West Coast in Oregon, I believe. So just an expansion of expertise. But I mention all that because Woolpert's just an excellent excellent group to just explain what's going on. What's out there. This is not an experimental webinar. We're not going to talk about the extremes of LIDAR, what's possible. We're going to touch on all that, of course, but mainly just focus on drone mapping and what's realistic, what's happened to date, and what you can expect from a firm that's closely engaged. Woolpert was the first surveying and mapping firm to be approved by the FAA to fly UAS commercially in designated airspace. Back in 2014, looks like per my notes. Since then, they've supported a wide variety of projects utilizing UAS. They've invested in numerous UAS platforms and employees. By the end of the year, expect to employ close to 30 certified pilots. That's a lot of trial and testing. Aaron Lawrence, our lead presenter today, is the UAS Technology Manager for Woolpert. He was also one of the first in the U.S. to earn a FAA Part 107 UAS pilot's license, so he'll speak to that too. We also have, again, Mark Treiber, Senior Systems Engineer with Teledyne Optech. He's here to answer any questions you guys have regarding their system, other systems. Recently unveiled a new system, the CL90, that we have a brochure if you have any interest in that. We appreciate Teledyne's support in making this happen, so glad to include that. Mark was formerly with Precision Hawk, which some of you might be familiar with, so he could speak to all that. So, without further ado, a lot of the stuff I've got here, notes for my intro, I know Aaron will go over here in a little bit, so it's probably best to hand it over to the man himself. Aaron, are you dialed in there?
Thank you, sir. Thank you, Alan. Yeah, first off, I just want to say I grew up in Southern Escondido, and so for all the folks that are in San Diego at the Esri conference, love that place. Just a quick shout out to friends out there. I don't have any family left over there, but it's a great place, great conference, and I think Alan was saying something like 19,000 people are there, so just an awesome feat for us geospatial geeks.
Indeed, Esri User Conference, yes, live, it's running strong, yes.
Can you advance me, sir?
Oh, yes, sir. Go right ahead.
Yeah, so, just quick couple words about Woolpert. I mean, Woolpert's been around for over 100 years, founded in Dayton, Ohio. We started actually flying aerial photography in the mid to late 1960s. As technology has advanced, Woolpert's advanced, and we've been buying. The main reason that I'm in this technology is because of the technology, right? So Woolpert has done, aerial photography and photogrammetry in the 1960s. In the mid to late 1990s, we switched from film to digital cameras, and then we started flying LIDAR in the late 90s. We have about 26 offices across the country. And again, as Alan mentioned, in the past couple of years, we've really just, it's just a huge investment in the tech. And we're strategically acquiring companies that sort of fit into our game there. So again, from 700 to 900 in a couple of years is pretty awesome. So as I mentioned, we started using LIDAR in the late 1990s, and we've the biggest thing about LIDAR was we were stereo compiling surfaces for orthorectification, right? So what we were spending essentially man hours dropping points on the ground to build a surface to orthorectify. Little did we know how much value there actually was in LIDAR, and the fact that you could do a whole bunch of other things. Again, feature extraction, and instead of dropping 1 point per 3 meters, we could get a couple, we could get 10 points per couple meters. So that was really where the big investment was. Woolpert was understanding that we were trying to build surfaces for orthos, and then as our research and development team started investigating remote sensing of things, we realized that there was a whole bunch more value in LIDAR, right? The LIDAR, like I said, gives you hundreds of more points than a surveyor could, although I will still say we still need surveyors. But basically, it allowed us to start 3D modeling and rendering of features and feature extraction of building heights, impervious surfaces from LIDAR intensity. There's just a ton more value. So again, that's one of those things where it's just exciting to see where LIDAR is going to go. And then now all of a sudden we're incorporating UAVs or drones into that. So just awesome. Also, red laser, most terrain mapping LIDAR is a red laser, infrared laser. We're also been involved in mapping the seafloor. And I don't know, there's a stat about, 90% of the seafloor hasn't been mapped. So Woolpert sees that as a huge investment in just, gaining a better understanding of our coastal environments and what's happening there. And then again, the entire statewide LIDAR projects. We've got the state of Ohio. We're doing a few others, Indiana. Those are, great programs. And for all the GIS geeks out there, I mean, that's data that's available to the public for you to be able to exploit, I guess is the best word, right? So there are entire states, we used to fly a river corridor and wonder where, the water goes, how the hydrology works. And now we have entire states worth of data where you can actually use that information and help you gain a better understanding of just a bigger picture, right? Scale it out. And then again, we're always involved. And again, one of my favorite things about Woolpert is we're involved in the cutting edge technology and building and designing sensors and or workflows. And so some of you might know about single photon LIDAR. We're just involved with that. It's cool to me. It's just a cool, it's a cool tech. Next, please. So, as Alan mentioned, we've probably been flying UAS since about 2012. In late 2013, 2014 is where the first sort of FAA rule came out for a 333 exemption, which the 333 exemption was essentially just exempting the pilot from being, a physical pilot from being in control of an aircraft. So the 333 exemption was, we still had to have actual pilots. They were the pilot in command, if you will, A lot of them didn't want anything to do with it. And a lot of them sat in a lawn chair and just watched while the operators operated. But, you know, we started flying for the Army Corps of Engineers, doing some coastal work. And, you know, at that time we were flying at 1,000 feet and, you know, in some cases beyond line of sight, there wasn't a rule. The 333 exemption came out and we, you know, we basically had to follow it. So a lot of the capability that we were doing in, you know, 7-8 years ago is not there without, you know, immense amount of paperwork and whatnot. So we fly. I mean, a lot of our work right now is just in consulting. We've learned the hard lessons, just about every hard lesson you could possibly learn. But we're believing that, you know, every organization, if they don't have a drone now, they're going to, and I mean public, private. You know, we're seeing DOTs starting their own programs. So a lot of what we're doing in our team is focused on just helping those folks develop their own UAS program. And so in some cases that's, you know, training, you know, hands-on training, how to fly the equipment, how to implement a program safely. I mean, the last thing any of us want is, you know, something bad to happen. So we're just focused on trying to, you know, help folks understand the rules. It's a full-time job to understand what the rules are, what new equipment's out there, and so we have a whole sort of staff designed to that. And I know there's a lot of groups out there that are focused on those things. So, but, you know, it used to be more flying and less consulting, and now it's sort of more consulting and less flying. But our big projects, the projects we're focused on are you know, repeatable projects for, say, construction monitoring, so change detection, what's going on. We're doing some work with Amazon and some of their new facilities where we're using a UAS once a month to essentially show the difference, the change between them. And that also helps downfield with how much dirt's been moved, are we on schedule, etc. So, and then also, you know, some folks just want to see what the drone's seeing, or you know, and so we're working on porting that to a desktop, right? So if we're flying and somebody wants to see what we're doing, they can log in and essentially see what the UAV is seeing. Again, traditional surveying mapping, that's a huge one for Woolpert. We're rigging up our surveyors. So we have, I think we have 100 plus surveyors. We're trying to put 100 plus drones in the truck. So if a surveyor, even if he just needs to use the drone to figure out how to gain access to a site, they have the tool in the toolbox. And I'll get into that with the next couple slides. But you know, high resolution imagery, no one's seeing. We have sensors that can see 1/4 of a centimeter from 75 feet away. Incredible. Like, to my remote sensing friends out there, we're used to looking at 10-meter pixels, and now we're looking at 1/4 of a centimeter pixels, you know, and what can you actually see? We're counting rivets on structures and bridges, you know, towers and bridges. And again, that's just, it's a new technology, and it's awesome. So, you know, I love this slide because it shows the technology. It shows what the capabilities are and where it's all going, right? So we have the BLK 360, which is basically a desktop laser scanner you could put on your desk, and it could scan an office, all the way up to a satellite that can be taking a picture of a specific area every day, you know, for a year or, you know, or more. And the critical piece is just understanding what the tech is. So what are the rules? What's the specification? I mean, at Woolpert, what we try to do is, a lot of folks say we just want a drone because it's cool. We would rather have you tell us what accuracy the data needs, what resolution the data is, or your data needs are, and then determine the right tool in the toolbox, right? And so in many cases, the drone is going in this same direction. And you can go ahead and move to the next slide. And so my point of this is, you know, we're still in our infancy of what UAS is, what the capabilities are. And as, you know, in one day, the rule could change. All of a sudden you can fly beyond line of sight, or all of a sudden you can fly something over 55 pounds. And that dramatically changes the game. Our fleet of aircrafts are 1970s Cessnas, and they're not going to be around forever. And there's not a whole bunch of aircraft that they're making these days that can fly at 100 miles an hour, low and slow. You know, everything's going sort of the jet engine. So the next round of tech for aerial photography is the UAV, is the drone. And so, you know, and we own all these, and I think everybody that's in the game owns all of them, or is thinking about them at least, which is, I need something that's small that I can pack into a survey truck, and the guy and my surveyor can go out and pull it out of the truck and figure out how to gain access. Maybe that's the only reason they're using it, but it saves a bunch of time for the folks that have been in the field. You know, you understand that. I mean, back 15, 18 years ago when I was in the field and I was mapping overhead facilities, you know, electric poles, I would have loved to have been able to pull the UAV out of my four-wheeler and send it down to take a look at a pole that otherwise was treacherous for me to actually have to get to take a look at. So we're looking at that. There's a huge push right now for LIDAR on drones, and we'll talk a little bit more about that. But these big in the middle there is just, I think, you know, people are using M600, but I would put a push for BFG, or, you know, there's a couple big heavy lifting systems out there that you can swap payloads and you can do a bunch of things with. And then obviously sort of the long endurance systems that are out there to, you know, capture large areas. Next, please. And so again, we talked about LIDAR on a drone or on a UAV. You know, Woolpert's heavily invested in testing these systems. I mean, at the end of the day, what we want a tool that can do some patchwork LIDAR for a statewide imagery program. Like, don't fly the entire county, do some change detection, figure out where we need to update the LIDAR and put it on a UAV. But in order to do that, right, we have to evaluate the tech. We want repeatable results, right? The goal is to be able to give an accuracy spec and make that repeatable. And so we've done a bunch of things. I mean, we're doing some work with Caltrans and California Department of Transportation in Fresno, University of Fresno, about they have a calibration field where, you know, what we're trying to do is figure out how many ground control points do you actually need, right, to achieve X accuracy. And so, you know, there's a bunch of research out there. And Alan and I were out in Nashville a couple of weeks ago watching the GeoQ folks, you know, trying to build a system. So as GPS and IMU technology advances and LIDAR technology advances and miniaturizes, there's just a huge opportunity right there for UAV, you know, based LIDAR. And, you know, our accuracy, we've achieved 2 centimeter. RMSE, we haven't quite made that repeatable yet. And that's really just us sort of looking at GPS and IMUs and the LIDAR systems themselves and figuring out. But you're able to capture incredible amounts of data, 900 points per square meter. And I often say this in talking with our clients is, it's so cool. US is so cool. And you go buy a system, but the other things you need to think about are hardware and software and processing power. I think that's something, if I could give to the group to think about, is it's a huge consideration. You're capturing resolutions and data at file sizes that are ridiculous. And so, you know, as you start to build your programs, or as you're thinking about, you know, entering the UAV realm, you know, that's a big consideration. Next, please. And so I think it probably everyone knows. I mean, our standard deliverables, whether it's LIDAR, and I'm going to try to make a point in the rest of this, you know, conversation to separate what a point cloud from LIDAR is and what a point cloud from autocorrelation is, right? But in the same regard, the same deliverables that we've been doing with a manned aircraft, we're delivering with unmanned aircraft. So you got your ortho photography and videos, and videos are becoming more and more important. Again, I'll talk to our Amazon project. You know, the folks in Seattle don't want to have to fly across the country to take a look at the site when we can essentially publish a new ortho photo in a video of the site. And so that's something that's new, and it's not necessarily for the geomatic folks on the line. You know, we're not videographers, but it's a cool way to sort of display what's going on. Obviously, DSM, DTM, so your surface models and the things that you need to generate a good ortho. But the other thing that's coming about is stereo compilation from, from a UAV. And so traditional photogrammetrists are used to looking at two photos and mapping the ground between two photos. Well, now all of a sudden we have 40 photos of the same target. And so we're watching these companies that software developers, you know, building software that essentially it's a data management software that, shows or manages which photos you're looking at and actually how to map the ground. And so we have some pretty cool results, and I'm happy to follow up with anybody on how that's working. And then obviously the colorized point cloud. Again, the difference between collecting an ortho and collecting LIDAR and fusing the two versus autocorrelation and creating a colorized point cloud from images, right? And I'll talk a little bit about the benefits of both there. Go ahead. So I mentioned Caltrans, and they have just an awesome site that's it's 88 control points or 80 plus control points that have been leveled survey. We also have one at our home base in Dayton, Ohio, which, you know, when a vendor comes out and says we can achieve 1/10 of a foot vertical accuracy with no ground control, we say, come on over, come on over to our site and prove it. And again, there's a couple benefits to that, right? The benefits are, one, how much control do you need to achieve an accurate product? I think there's a graphic if you click the screen, Alan. There you go. So between the case D and case E, you can see what 2 more additional ground control points do at the site. You're dramatically increasing the accuracy, both in RMSE and in NSSDA vertical accuracy, which is highlighted at the bottom. And the point is for Woolpert is what we're trying to do is figure out how many ground control points, right? We still are firm believers in ground control. So what we're trying to figure out is, okay, we're going to use a UAV to fly this site. How much ground control, how much ground time do we have to spend in order to achieve the accuracy that we're talking about? And it's not a one-off thing. It's repeatable. What we're trying to do is create repeatable results. So I'll go back to the cell phone. There's a new shiny object every month that comes out. And that's from Aaron going, wow, that's really neat. To my organization saying, listen, it is really neat. But what we need to be doing is creating repeatable results. And if it means we're using a legacy system, but we're continually producing the same accuracies, that's really what we're looking for. Next one, please. And so again, I want to try to make a difference between LIDAR, a point cloud from LIDAR, and a point cloud from autocorrelation. And the advantages of a point cloud from imagery are it's cheap, so you're not flying it twice, or you're not flying imagery and LIDAR and then spending a ton of time trying to fuse the two data sets together, right? We're flying it once and using it a bunch. That's what we say a lot. It's affordable, easy to deploy. It says easy to process. I mean, that's debatable. Depends on how many images and what your hardware and software configurations are. Obviously, with these auto-correlated point clouds, we're flying excessive overlap and sometimes 80, 90% overlap. So, sort of just a critical thing to think about. And then again, the disadvantages of LIDAR, and I'm a remote sensing geek, is, the point cloud from an image, point clouds from autocorrelation don't give you canopy penetration. You're most likely not going to see the ground in numerous cases, even in a sparsely vegetated area. To see the ground with autocorrelation is hard. And so if you're trying to build an accurate DSM that's obstructed by vegetation or other features, autocorrelation may not be the right answer. And again, we're also limited with right now with vegetation. So if you're flying a highly vegetated area, you're talking like in the Carolinas or something, you're talking 70, 80 foot tall trees, and that thing can go out, go beyond line of sight really quickly if you're standing on the tree line. And then so you separate yourself from that and you move yourself back, and all of a sudden, you're limiting the area that you can fly because the UAV's out of sight. So just, there's a big difference in the tech between autocorrelation and LIDAR, and they both have great benefits. And this is just an example of, this is a point cloud, not an image. So 210 points per square meter. I mean, you're talking about terrestrial LIDAR scanning densities. That's a point cloud that we're looking at there. So just incredible, what you can get from this data. And again, the imagery also, if you move to an image, you would see that we're talking about 1/4 of a centimeter from 75 feet away. So, I would ask the audience, what sorts of things are you looking for at that resolution? Next, please. Yeah. So a lot of questions we get, and we're doing a lot of UAS work with departments of transportation, and they all have sort of each state has its own individual accuracy requirements, documentation, etc. And so I would just highlight an article by our chief scientist, Qasim Abdullah, who is an authority on the technology. I mean, this guy's looking at weird stuff like how accurate can you get it? This new article is basically a summary of what the new ASPRS standard is for autocorrelated data, right? So he's basically breaking down what the new standard is. Like, I had a price proposal come in the other day when someone said, 1 inch equals 20 feet. And you just think like, well, that's on a paper map. Well, I mean, there's not too many people. If you're in the field, I understand you probably need a paper map, but most of us are using tablets and, you know, whatever else to try to understand digital data. So basically what we're saying is if you're going to use UAS for a survey and you want somebody to sign off on it, demand a photogrammetric workflow, right? This is a lot of times people want to go to whatever software you're using, Agisoft, Pix4D, Menchie, SimActive, press the button and go. And we're saying, no, you know, you probably need somebody that knows a little bit about aerial triangulation to take a look at it at those intermittent steps and make sure that it's doing what it's supposed to be doing, or that you're achieving what you're trying to achieve. And then again, the mapping standard. And so we're talking with folks, and they have, again, their you know, their accuracy standards are outdated, and there's new ones. And so I know that's hard to sort of accept, but we're trying to just bring awareness that there's no sort of a new digital accuracy standard. And the way it's written out, we don't have time for this, and I'm not putting Custom on the spot, but if you really want to know, you should talk to him, because that guy can go deep. Next, please. And so again, UAS isn't always the best answer for everything. And this is just a quick example of, you know, the data fusion, basically, right? We have surveyors on the ground. They have terrestrial scanners. We have mobile LIDAR systems that are collecting the road and at the highest accuracy possible. And we have statewide LIDAR and imagery programs. And so this is just a quick sort of highlight of one of those projects. Next, please. So again, I don't know if this is automated or not, but this is a project where it's in Amish country in southern Ohio, and essentially it's a dead man's curve. Basically, there were Amish folks and folks pulling out that are getting killed, and so the state of Ohio has, you know, basically asked to go out and do first of all just an investigation of the site, and then you know, a bigger detail. It's a hump, basically. So at the intersection of those two roads, and I don't have a pointer, but you can see the intersection of the two roads there. That's a knob, and so people are flying from the west, coming over the hill, and running into people and hurting them. So the goal is just basically, or killing them, is to take that thing, break it down, look at the hydro, also. So you can move on. And so our solution was basically, well, we have great LIDAR, you know, we have great Woolpert LIDAR for the state of Ohio. Let's look at that. Okay, well, that's pretty good, but it doesn't give us a good idea of the detail of the road. So let's use a mobile mapper. And again, that blue van there is equipped with Optech LIDAR systems, 2 of them and 2 cameras. And so we're talking about the accuracies of all, right? So the mobile mapper can drive down the road. That's what it's made for, is to make highly accurate digital representation of the existing conditions. Then we used UAS to capture what the mobile mapping system couldn't. And then outside of that, we used, you know, our existing LIDAR to help us with the hydro. Obviously, if you're gonna level a knob on a road, there's gonna be effects to, you know, hydrology of, you know, of the system. So just a quick spec on those is, you know, with the point densities with the manned aircraft and LIDAR, 30 points per square meter, mobile mapper 2,000 to 6,000, and you know, the unmanned system there, you can see 40 to 1,000 points, and you can see the RMSE. Go ahead. So again, this is the ultimate project. This is what you want. This is what Aaron wants. I want to see the best technology used in the best case. And so in this case, we drove the roads with the mobile mapper. And again, you can see the accuracy there on the left there. It's incredible what we can achieve driving at 30, 40 miles an hour down a road. Next, please. And this is basically a flight path for what we did with the UAV at 100 foot. So if you look sort of close, you can see the blue X's. Those are ground control points that we actually used to control the UAS mission. Next, please. And you can see the achievable accuracy there. Again, we're basically using the highest accuracy tool, the mobile mapping system, or first of all, I should say before that, the ground control. The surveyor still has to go out and lay some targets, maps the ground out, and then you can see the UAS data. Next, please. And then what else we didn't get with the UAS, which is less critical, but it's still important, which is the sort of hydrology of the area. We can use a data set that already exists, right? So a LIDAR data set. And again, you can see the achievable accuracies. Next, please. And so what we're doing is taking the best of breed. So we're trimming what we know what's great about mobile mapping. As you get further away from where the LiDAR scan is to, outside of that realm, let's trim it away and let's use something better that we're more comfortable with. Next. Which is the UAS data. So now we've trimmed out the section where the UAV data that we have confidence in, and we're inserting a point cloud, a terrain data set that from a DSM. Next, please. And again, and then one step further, after we've done that, and we're saying, you know what, chances are this farm field probably hasn't changed so much in the past year. I think it was a year, probably a year-old LiDAR data set that we used, and then we insert them all together. Next. And what you get is, I think you can just go ahead and go to the next one, which is all of the data together, right? And so it's just a beautiful fusion of data where we get the larger problem of hydrology incorporated in the real problem, which is there's a knob and people are dying. And so this is just a great way to fuse all that data together. Next, please. And well, I thought there was one more, but basically, the point there was just, putting all that data together and just getting a great understanding of, how all that data works together. And what's critical about that is the geomatics, is about understanding ground control, locking all that data together, and then sort of presenting that to the engineer that has to ultimately make the decision. I mean, that's what we're trying to do, is provide as much information to the decision makers so that they can make the right design on that.
Indeed.
I think that's it for me.
Yes, those conclusions, Aaron, we appreciate it. Mark will give us just the manufacturer perspective here for a bit, but please, if you have any questions, you can submit Q&A now. We've got quite a bit of advanced Q&A, or quite a bit submitted initially, so we'll do our best to get through it. We don't want to stay on too long for you guys, but know that any significant questions, we can follow up. I'll get a copy of these to Aaron and to Teledyne. So please, if you have any questions, ask now. But yeah, from those conclusions, Mark, are you connected there regarding kind of your wrap up?
Yes, I am. Thanks. Yeah. So from excuse me, from our perspective, so recently we introduced the CL90 laser scanner onto the market, and really what we're trying to address there is we're bringing a LIDAR scanner that's custom designed for the UAV market. And so what do I mean by that is our sensor basically is an active LIDAR sensor where all the shots are basically focused on the ground. So you're not making a trade-off with for example, a 360-degree scanner where you're losing a lot of those shots. All the shots are focused on the ground, and as well, we've got a strong eye-safe laser. So we've basically designed a system that's designed to fly at 400 feet maximum altitude, so to maximize the productivity, but at the same time getting excellent vegetation penetration, especially when you run at we've got the flexibility in our sensor so you can run at a lower laser pulse rate to get excellent vegetation penetration, or run it at a higher pulse rate, which results in a lower laser power, but you get a higher, more shots on the ground, higher pulse density and point density on the ground. So a system that allows you to trade that off to basically customize the performance of your sensor for the application that you're trying to survey at that time. So.
Yeah, no, that makes sense. Aaron explained, hey, for them it's about repeatable results. The best technology in the best case, but at the end of the day, it's repeatable results. So that's good stuff. Mark, unless you have anything extra, I mean, we'll move into to Q&A. I assume you're good there. An initial key question that come through was regarding that. Was that an ebook, Aaron? Kasim's ebook? Was that something you guys published? Is that available for free?
Yes, sir. I'm happy to provide the link. Yeah.
If you give it, if you guys don't mind, we could perhaps provide it as part of the follow-up. Like sure folks would like to see that. Like you said, He can go as deep as you like. He's written for the magazine. We appreciate his viewpoints. So yeah, absolutely. If you could share the link, we'll include that with the follow-up. Several questions regarding computing power. You made it clear, Aaron, that's a huge consideration. You're dealing with a lot of data. This is the type of thing that we built a traditional machine. What do you recommend? Or, I mean, can you speak beyond just, hey, you need the best possible, configuration you can afford, or can you speak to that at all as to actual systems used, or?
I mean, I'm just a firm believer in ground control, and I think Woolpert in whole is sort of adamant that no matter what anyone's saying, you need to have a surveyor on the ground putting targets. So even if you don't use them in your solution, at least to confirm that you're achieving the accuracies that you're stating. And then again, that tech is GPS and IMUs. It's incredible, that we've gone from, basically weaponized, GPS and IMU systems to something as small that can fit on your aircraft. So, in general, I would just say, you need to also, not only do you need to think about the sensor, you also need to think about the inertial measurement unit.
Absolutely. That's perhaps something we could provide additional links to, or an additional research. You mentioned a little bit of this. We've covered a lot of ground today, but typical flight time. I mean, I know you're using a variety of systems, but can you speak to flight time and to weather? When do these things really work? I mean, a fella mentioned he's in a northern climate, and that this all sounds great, when we're sitting out here in San Diego, but with extremes in temperature, what does that do to flight time? I mean, just weather in general, what does that do?
It's just a big consideration. Like when you're laying out and specing a project, you need to be thinking about that stuff. And again, I'll go back to just accuracy statements, and optimal conditions, pretty much I knock off 20% off whatever manufacturer says the flight time is, because typically I'm not flying in San Diego in 70-degree weather and on the coast or in a flat area. I'm flying in Pennsylvania where there's extreme terrain and it's 95 degrees or it's -5. And so those are just things that, again, that there are companies that are focused on that, right? They're focused on trying to help me in Pennsylvania, get my work done. And so, yeah, it's just, it is a definite consideration. So in regards to flight time, if it's too hot or too cold, you're going to lose more time than you thought. And you're probably going to either be sitting in the truck with the AC on, cooling it down, or in the truck with the heat on, warming it up.
You mentioned sending each surveyor out. That was interesting with you. I ran a statistic, and there were quite a few. I'm sure we could extrapolate all manner of stats from the registration, but close to 20% of the folks that registered outsource this service currently. They guess if there's a need for it, they outsource it. Is that something you could do with Woolpert? Do you guys take on, I guess, just any comers? Could someone outsource this work to Woolpert? Another firm that perhaps couldn't do it? Or can you speak to outsourcing in general? Is this a service that, are there 1-800 rentals type things out there for folks?
Sure, that's great. It's awesome. And, again, as I mentioned sort of at the top of this was, we were flying a ton for a long time. We were flying a bunch everywhere. And we started realizing that everybody and their brother is going to own a drone, right? And so, we're focused on helping people build programs. We want people flying data, and we want their data. We want to put our expertise of photogrammetry and geomatics to the test. I looked at our UAS implementation is like what we were doing 15 years ago for GIS implementation. We were helping people move from CAD to GIS. Now we're helping people move from, just hiring and all that to doing their own stuff and making sure that they have the workflows in place and all of the tools to be able to build their own program. And yes, there are rental systems. And again, it's a great business model because I'm not going to go out and buy the latest and greatest system. I'm going to buy the system that works. And so if I can call 1-800 UAS rental and get somebody to fly a LIDAR system for me or whatever it is, right, of a chemical sniffer, right? I'm not going to go buy a chemical sniffer, but I'll tell you what, we do get lots of asks about, do you have a system that can, tell me if there's, a leak in our pipeline or what have you. So those organizations exist, but I think, we're leveraging them to a degree. And I guess that's, they're out there and they're helping a lot of folks figure out which path in the, which business model they want to take, right? If I can all of a sudden get, 100 projects that are chemical sniffing, I'm probably going to buy a chemical sniffer. And having those organizations that are sort of renting those systems or offering those services is great. It's great for the industry.
It is, and you guys, Woolpert's done a wonderful job of sharing that information. Not just from an awareness, perspective of, say, the geomatics community, but for potential buyers or just folks that are looking for solutions. It's helpful all around. So I'd say not an issue of LIDAR Magazine goes out without a contribution of some sort from Woolpert, which we very much appreciate. I know the industry appreciates that sharing. A couple questions regarding how long the systems last. I guess that's kind of just something you could determine from. I know this is all case by case. It depends.
No. It's a great question, and I wish they last 10 years, but the reality is not. And again, I think part of the reason that we've moved to the consulting gig, I mean, we still fly, so don't get me wrong on that, but is we've learned some of the hardest lessons. Like I said, we were flying before the 333, and we had, you know, a significant amount of dollars invested in a system that, you know, 3 or 4 years later was no longer worth a dang. And, you know, and so that's a very hard thing. I mean, our model changed when I basically said, no, we're not going to buy, you know, these massive expensive systems because they're going to basically depreciate in 2 or 3 years, and they may not even be useful in 2 or 3 years. So, I mean, I guess my guidance for anyone that's listening is think about that, and think about your cell phone, and think about how long you keep your cell phone. And I would basically, you know, use that as the model, because again, we're still in our infancy of UAV manufacturing, and what technology is available. And it's, you know, one advancement can exponentially change the whole industry in a second. So it's a scary thing, and I didn't mean to say that to scare everyone. I just meant that to say, just keep that in consideration. Like, I can't afford to chase the shiny objects. I need repeatable, dependable stuff.
Absolutely. I hope we made that clear that we could host a webinar regarding extremes and all the cool stuff that's being done, all the R&D, all the development out there. But I think folks want a sober, realistic, measured, no pun intended, viewpoint or approach to all this. There was a question right as you asked all that regarding whether or not it was best to wait. It's never going to be, there'll never be a perfect time. Do you think this is something that every firm, say just traditional surveyors, surveying and mapping firms, is this something that they just have to, at some point sooner or later, just have to specialize in, or at least have some sort of understanding? I believe so. But it's probably, now, if you've been at this, you said 10 plus years, I'd say it's quite developed as to, as opposed to where it was. So now's as good a time as any. Are there solutions that you know of? We've seen some for 10K, 20K. Is there a threshold there? Like we saw with laser scanners, that the floodgates open and this becomes, I wonder what that number is. But
I don't have a number, right? I don't have a number, but my opinion, and I think Woolpert's opinion is, it's a tool in the toolbox, and I want to enable our surveyors to use it, right? If they're doing a topo, like, what's a better deliverable, a topo or a topo with a brand new ortho? You know what I mean? Like, sure. So to me, like, that's what we're trying to do, is basically just say there's an additional service, and it's a couple extra hours out there. Again, depending on the situation, but to be able to provide super high resolution, brand new orthophotography over a topo site that you have is, it's invaluable. So, again, in terms of dollars, I don't want to spend $20,000 on 100 surveyors for, to put, $20,000 systems in 100 surveyor trucks. I promise you that. But we're always looking at the different systems and what's out there, and like, what's the best way? What's the most efficient way for our clients and our folks to be able to collect data?
Yeah, no, we're at a point now where they're, like the optics or the Teledyne CL90. Most of the major manufacturers now have a solution, but there are integrators across the country, around the world, several that specialize in, and now there's even credit packages available, rental services. So you can get involved with this without a major purchase. You can, get as involved as you like. Yeah. Now. I'd say, folks, it's the cat's out of the bag, and folks are aware of what what the systems can do. So we're past our wrap-up time. So a lot of remaining questions are in regards to last files, GIS integration, spec type stuff that I think perhaps it's best to just follow up directly on. But anything else in closing, Mark or Aaron, that you think we need to state?
I mean, I'm good. I appreciate everyone joining. I'm sorry for the little technology hiccup there, but if you're in UAVs, that happens all the time. So I'd encourage you to reach out to me at aaron.lawrence@woolpert.com if you have specific questions. And again, I'm happy to help LIDAR Mag and all that stuff with whatever else is a follow-up.
Absolutely, we appreciate it, and we've Teledyne, Mark, we appreciate your support and just making these events happen and helping us get this information out there. We thank Woolpert and everyone involved. Mark, anything else you'd like to add?
No, that's it. Thank you, and thanks to the audience for attending.
Indeed, look for the follow-up. We'll send you everything. We'll get that recording clipped, so you won't have to worry about that little hiccup again. We appreciate your patience. If you need anything, just respond to the follow-up message or reach out. Just let us know. The email's in your registration confirmation you've already received, or again, the follow-up will be there within a day or two. So thank you so much for attending. We appreciate your time.
Thank you all. See ya.